Let me know when you can see my screen.
Yes, I see.
Yeah, it's visible.
Okay, so we'll start today by trying to solve the question which Benjamin put forward. So we have this question. Using a for loop, create the list below, which consists of ones separated by increasingly many zeros.
I don't understand.
Let me mute. The last two ones in the list should be separated by 10 zeros. So great, and they gave an example of the list, so you can see the example, what they want us to generate here. The first one is there's no zero separating it. Then you have 1, 1, 0. You have another one, the zeros are 2. You have another one, the zeros are 3, and so on and so forth. So does anyone have an idea before we go into how we think we can approach it? Because there are many ways, but let's just see if any one of us can think of anything for it. Can anybody? Anybody saying anything? Okay, first of all, we need to understand the way the list is composed. It's like the list has 10 1. Like, because the last two ones in the list should be separated by 10 zeros. So I assume the list is not infinitely long. So to form this list, we can use first of all, you initiate an empty list.
Excuse me, sir. Good evening.
Good evening.
Sorry, I joined late. Where did you get this question from?
Benjamin.
Sorry?
Benjamin gave us the question. Where is it from, Benjamin?
Because I can't find it in.
Chapter 7.
Oh, okay.
Chapter 7, number 11. Correct?
Okay. Okay. Thank you.
Yes, chapter 7, number 11.
The idea is I have my for loop. Because I assume it's maybe 10 long, so I said 11. So what we are going to do is we run this, and each time we are going to append 1 to the list and 0 based on the loop variable I. So each time we append number 1, and after appending number 1, you will create a list of zeros. It should be equal to, let me see, how do I? Okay, I think this should do it. Let me run this first and see how it plays out. So, okay, we are almost there. So I have the list 1, then 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, and so on and so forth. But okay, one more condition. The last 2 ones in the list should be separated by 10 zeros. Let me check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that means I'll add one more 1. So, no, append 1. Okay. Okay, so Benjamin, you see how I approached it. So, yeah,
Okay.
you want to say
Yeah, go ahead.
something? Okay,
I want to
so
say, under what condition she will be initiating an open list?
like I did in line 9.
Yes. Under what condition? That okay, in a situation like this, these are the conditions for open list. Then we'll now begin to write the criteria, the program itself.
Okay, so to solve this question the way I saw it, right? I saw that we can put 1, then after we put 1, we'll put the 0, then we put 1 again, and the zeros are changing in terms of serially. The first one, the 0 is nothing, right? There's no 0 separating them. After the second one, there's 1 0. After the third one, there are 2 zeros. And then the 0 keep increasing, 3 zeros, then to be 4 zeros, then the next one will be 5 0, right? So the 0 is gradually increasing according to 0, 1, 2, 3, and so on and so forth. Does that make sense?
Yes.
So for me, that immediately looked like something that I can achieve using a for loop variable, because for I in range 11, I know that I will begin to change as 0, 1, 2, 3, and so on and so forth. So I already know that I can use a for loop to achieve this sequence. There may be other ways to solve it, okay? I just thought
Can we
about
use
this.
count?
Sorry?
Count.
How do you want to use count?
Maybe count equals to 0. After declaring this first empty list, can we still have each count equals to 0?
If you want to count and use count somehow in this solution, why not? The only thing is, this is the way me I solve it, right?
Okay.
Based on how I understand the question. And in my own solution, I did not see the need for count. But if you have a solution that has the need for count, there's nothing wrong in that. Okay. The way I solve it does not mean this is the only way to solve this problem.
Okay.
Okay, so now I'm trying to explain why I had to initialize an empty list. So because I know in the for loop, I'm going to be adding up element to populate this list. That was why I have to initialize it before my for loop. Okay. So what did I do? Each time in the for loop, I add 1. So the first time I put 1, then I created this using list comprehension. I created another list. This list is a list of zeros. So I said, put 0 for I in range I. Now, the first time I will be 0, so this does not form anything because I in range 0 does not bring out anything. So this Z amounts to nothing then. And then I use dot extend because when you want to add another list to a list so that it will form like an extension, right? You use extend. Luckily, I know that method. So if you use append, you'll get a different result. What you will see is, let's change it to append, and you see how it will be. Let me see if I use append, yeah. Let me save it and run it. So you can see what append does. It appends the list Z. So after 1, you find out Z is empty. Then another 1, you see Z contains 0 because the next I will be 1. So at least you have 1 0 in this list. The third time to contain 2. The fourth time. So you see the way it came in as list in a list. Okay, but we don't want it to be like this. We want it to be that this list elements, we join the original list as normal element, the way it is in the example. So one way you can do that when you're adding another list to a list, and you want the second list you're adding to the first, the elements should continue the first list, right? You use dot extend. So when you use extend, you can see the difference, right? When I use extend, you see that when we run it, the zeros are appearing as if it's part of the list, not as if we are putting another list item in this list. Does that make sense?
Yes.
So I use this one now to generate those zeros according to the loop variable here, which I called I. Okay. I can even change this one to J. Yeah. Oh, still, yeah, just to make a difference. So whenever I is 1, this one will become 1 0. Whenever I is 2, this one will create 2 zeros. I is 3, this one will create 3 zeros, and so on and so forth. It keeps increasing this. Then I keep adding it. After 1, I'll add the zeros, but the zeros will be changing according to 0, 1, 2, 3, and so on and so forth. And then the question said the last 2 should be separated by 10 zeros. So I assume that they needed the list to be up to 10. Okay, because the zeros keep increasing by 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that was why I put this one as range 11. So it will stop at 10. So if you watch, after I stopped at 10, I now appended another 1 outside the for loop so that this 1 this is the last one, and then you have 10 zeros, and then another one to fulfill those conditions. Make sense?
Yes.
Yeah.
But I mean, when you use append, I didn't see the result too.
Everything is added to this empty list using append. So here, you first
No,
of all,
you replace when you replace the extend with append.
you look at it again, look on this side, the terminal. This was the solution when I used append.
Sorry, did you get my question?
Yes.
There was a difference because it showed an empty list first, or displaying other ones. I saw it. It affected it. Yeah.
Okay.
And if you look at the screen, I'm highlighting it.
I had
When
looked
I
at it. Yeah.
used append, see what came out. You can see
Where?
that all the zeros are as if they are in a list of their own. Okay?
Yes.
They are separated by square brackets. So they are actually not part of this initial list. So it's like list in a list. Let me do something again that might just show us the difference more so that we'll see the difference between append and extend. You have, if you have this list of A, comma, B, A and B, and I intend to add this list to it. This list contains C and B. C and D. Now, if I use dot append, this is what it will become. It will become something like this. Do you see this? If you use dot append, this is what you will get. So this list has 3 elements. You have A, B, and the third element itself is a list.
There's another list.
So another list, yeah. But when you use dot extend, this is the way it will be. So when you use dot extend, the elements of the second list, they join the first list and they have, like now is 1, 2, 3, 4 elements.
Continuation. Okay.
Continuation, sort of, exactly.
Okay.
So that's the
Okay.
difference. This is append, this is extend. So if you look at the terminal, you observe that the one with append is having the square brackets as if you're adding another list there. While the other one with extend is just like one single list. Okay. And then he sent a second question. Benjamin.
Yes,
Benjamin.
I'm with you. I'm with you.
Should we keep solving all these
Hello.
questions today? So you packed many questions and brought.
6:30. 30 minutes gone.
Okay, no, let's continue. Let's continue for the class for today. At least I've captured this one.
Okay.
Thank you.
Or maybe after the
Yes, give me-
class. After the class.
Okay,
we can
after the
then
class.
solve.
Yeah.
Yeah.
Okay, sir.
So let's continue. So today, we are going to talk about while loops. Okay. So the topic for today is while loops. Now, we already know of for loops. We already know for loop, right? used for repetitions. There is now another loop we are being introduced to today, which is called while. While loop. While loop and for loop are very similar. Like they do similar kind of things, repetitions, but just the structure differs a bit. So in other words, almost anything you can do with a for loop, you can do it with while loop. Okay. Now, while loop has the syntax. After you write while, you then put a statement, or should I say condition. While this condition holds, you continue to do something like this. Something like this. While true, I can say print, just print yes. Okay. So this is like the structure of a while loop. You have this, the word while, and then your condition. Here now, I just say true. Why true? And then I print. If I run this like this, it's not going to end because it's like it doesn't have a condition of stopping. So why true? True will always just be true, 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 true. And this will continue to print. It will be looping, looping. But I can say something like why I is less than 10. Let's say I have I in the beginning, I equal to 0. Right? And then why I is less than 10, print yes. Now also there have to be a condition to increase y was equal to 1. Okay, so here now I'm increasing I by 1. I equal to 1. The next time you run it, I plus 1 again, I will be 2, 3, 4, 5, like that. Let me print it like print I, comma. Let me now take this one to comment. Good. So now you see what's happening. This is a while loop. And we have our while statement and the condition I want to achieve, because in this case, I want to print 10 times. So I'm checking why I is less than 10. So the first I is 0. And then when it enters the loop, there's this line to increase I. Okay. This line here increases I, and I will become 1, 2, 3. So let me save it and run so you see what I'm talking about. So if you observe, the first I is 0, we have yes, and then I is 1 because I is increasing. This continues until I is equal to 10. Okay?
I thought it's less than.
Yeah. Once it is not less than, okay, the condition breaks. So anytime I is less than 10, this will
Will hold.
happen. But once I
Okay.
is equal to 10, I is no longer less than 10. This will not hold. It stops. If you want to include 10, I think you can
Equal.
less than or equal to, right? Run it again. You see, so now this captures the fact that it can be less than and also when it's equal to. So if it's equal to 10, the loop will still run. But once it's greater than 10 now, it won't run again. It stops. So you see your result. Okay. So one difference between for loop and while loop, this same thing I wrote here is the same thing as in for loop. Somebody will say for I in range 11 because 10 now is included. Okay. Because 10 is included. For I is in range 11, then I'll just take this. Say print I, yes. These are two the same loop, but one is with 4 and the other one is with while. Okay. But you see, while loop, one major difference is while loop can be used when you don't even know the amount of time you want to repeat. For loop, you need to know the amount of repetitions you want to do, which is where the range comes in. Even though you're not using the range, you can say when you're saying something like for I in range, you can see len A, assuming that A is a list. Or let me say, assuming that A is something. A maybe is a string, it's an iterable. If A, for instance, is an iterable that has a length, right? I can do this and it works because len A will give me the length of this iterable, even though it's a list or a string. A string is also an iterable. That's why I could use a string. It could be a list. I can do this, but what the key thing is, this for loop knows the beginning and its own end. Okay, length of this list is a fixed number. So the for loop kind of knows when it's going to start and when it's going to end. But in while loop, you can run a while loop without even understanding how many times you're going to run it. I don't know if that makes sense.
Okay.
Yeah, so a while loop, infinite number of times, you can just run it. That's why I can tell you something like while true. You know, in the beginning, I put while true. When I say that now, there's no reference to how long true is going to be true. True is going to be true like forever. So that loop will run and run and run and run until like infinity. Infinitely, it won't stop. So if you also like this one where we say I equal to 0, if I forget to put this line here, that increases I. You remember, if I don't put this line, I will forever be 0, right? And when
Yes,
I
to not knowing.
is not increasing, this loop too
Increasing.
can run forever. It's not going to stop, even though it looks as though there's a condition here, but the condition will never be met. But for loop, there's always like a kind of range, or even if I can even say for I in A, I can do it like this for I in A. But the thing is that there's a number of I that is in A. It's not infinite. I'm just showing you one major difference, but both of them are loops for repetition in Python. So almost anything you can do as a for loop, also you can structure it into a while loop. But not everything you can do as while loop that can be structured into for, because of that advantage of while loop that can handle unknown number of events. Okay, so we can write a program where, so far as the user continues to supply input, it should continue to run. It should continue to run like that until maybe there's we can give a condition where the user can then stop it from running. So with this now, you see that we've actually touched on these two, right? While loop and infinite loops. Okay, so these infinite loops are those ones where, for now, like this, where the I does not increase, you have created an infinite loop. Okay, you have created an infinite loop, and this infinite loop can also be used. You can even use it and use all the memory in your computer. For instance, if I say while true, and then I keep making a variable that is just assigned something to a variable, it's going to continue for a long time. But the thing is that the memory in your computer will be using up, something like that. You can just use up the memory in your computer. because it's going to continue like forever. Okay. Do we have any questions so far?
Is this the same as nested loop?
No, not nested loop. Nested loop talks about a loop in a loop. Okay? A loop inside a loop. So I have this for loop, and then I come inside here and I still have another for loop. For loop. Something like this. So you can see that I have the first loop, but the second for loop is inside the first loop. This is nesting. You're putting it inside. Generally, also, we try to avoid this kind of pattern, but sometimes you can't avoid it because it makes your code spend a lot more time. You reduce the time efficiency of the code. So if there's another way you could do it without nesting, it's going to be favored. You could even have another for loop inside this for loop, and you continue to have other for loops in for loop. Nest as much as you want, but it's just going to make your code more complex. Okay. So that's nesting. So are we clear on the structure of our while loop?
Yes.
Yes.
Okay.
Yes.
So now the other thing is to use this while loop in problems, to introduce it in problems. So some of the problems you solve with for, you can use while. And like I said, there are some that you can use while, you cannot use for, like the one that you want to run infinitely, where maybe the user needs to supply, you want the user to be able to do something a number of times as much as the user wants. And then when he wants to exit, you can then say exit or enter a negative number. So let me just put it like an example, what I'm trying to say. Yn is greater than 0. First of all, you could say n equals to eval